Hi everyone, good evening. Welcome back to our channel. Today, let us try to find out the H parameters for the common emitter transistor equivalent circuit is shown below. Find the H parameters. If you want to find the H parameters, we want to apply Kirchhoff's current law at input port. So apply Kirchhoff's voltage law at input port. So the current entering this point is some IA and entering is positive terminal, leaving is negative terminal, entering is positive terminal, leaving is negative terminal, and already just a small modification already given is an negative terminal. So actually uh, we have to write down the standard format V1 I1 and V2 I2, but here it is given as VA IA VB IB. Okay, this is designated. So now we want to write down VA IB in terms of H11, H12, H21, H22 multiplied with IA VB. So now the resultant we need to get is we require the equations of VA is equal to H11 IA plus H12 VB. So this is the first equation, and second equation is IB is equal to H21 IA plus H22 VB. So that is the second equation. We want to express in these two formats and variables. So whenever the current is leaving, the leaving terminal is VA. So therefore we are going to get as plus VA, and current is leaving. The voltage drop is leaving terminal is minus IA RB. The leaving terminal is like this. For the leaving terminal we have minus the current is IA into RC, and this is also a voltage source. I mean voltage, this is nothing but voltage dependent polarities are there, voltage source. So this leaving terminal, what is the current leaving terminal is minus, what is the magnitude, this is mu BC VB equal to 0. So now we require the expression of VA. So the expression of VA is equal to, when you move all these terms to the right hand side, IA RB plus IA RC plus mu BC VB. So this is the term, and I'm taking IA as common here. So VA is equal to, if you take IA as common, this is RB plus RC and mu BC BB. Compare with this equation, therefore this is H11 value, this is H11 value. So this is H12, this is H12. Okay, so let's try to write down it later. Okay, and now here we are going to apply Kirchhoff's current law. So what is the entering current? The entering current given is IB. Okay, so IB is equal to, so mark this current as some IX. So IB is equal to some IX plus the next leaving current is alpha CB multiplied with IA value. So we require IB. So IB is equal to, how to write down the Ix? The voltage at this point is VB. Automatically the voltage at this point is also VB. So there is nothing but VB minus 0 divided by R E plus R D plus this is alpha CB multiplied with IA. So when you multiply this, compare with this equation. So this is H21. So this is H21 and H22. Sorry. So this is the value of H22 multiplied with VB, and H21 is this value. So now let's try to write down in a matrix form. H11 is equal to RB plus RC. Next, H12 H12 is equal to mu BC. Next one, H21 is equal to alpha CB. Okay. Next, H22 is equal to 1 by RE plus RD. So generally this is ohms, this is mhos, this is the gains. Okay. So here we are going to have this is reverse voltage gain, alpha is the forward current gain. So these are the values of H parameter. Okay, very simply I applied a KCL at input port and KCL and KVL at input port and output ports. So successfully I have been find out the H parameter. First write down the KCL and Raster express in the standard format. So we know this V1 I1, but I written in terms of VA IA as input port, VB IB is nothing but the output port. Hope you are able to solve. So directly if you see this video, you will not get the content. Just write down the given problem and solve of your own and verify with the answer. Hope you had understood the problem. If you understood the problem and if you feel the problem is very clear, please like the video, please share with your friends, and if you have any doubts, let me know in the comment section. And if you're watching for this first time, subscribe the channel. This is a free channel for the development of students and faculty. So please kindly encourage. We'll meet in the next video. Viewers.